Okay, so now we come to the topic of collections, which is a kind of alternative to arrays, maybe a more modern alternative to arrays. And we already saw the concept of structure, so it's a little bit like a structure. And we also saw that you could use a structure in an array sort of to make it a little bit more convenient. However, one of the problems with arrays is that changing the size of an array is not it's not done very well, and also adding elements in different locations to an array is not very easy. So they say historically arrays are the primary structures for storing sets of data. And for years, they were the primary storage mechanism for in-memory data manipulation. So by in-memory, they mean as compared to maybe you have a database somewhere and you can store data in the database. That's a little different. This is stored right in the local computer, and it's basically stored in the memory so that it's very quickly accessible. They say, however, arrays are being replaced by more flexible and more powerful structures, so-called collections. So here he says he discusses collections in detail in chapter 12, which we won't get to, but we're going to just briefly talk about them here, so you get some idea of what they are. And he says collections are used a lot in programming. So he says a collection is a dynamic data storage structure. So dynamic means that it can change size, and so like an array is basically just one size. It can only you have to tell how many elements they're going to be in it, and you can't really change it. But a collection is not that way. So they say you don't have to declare the size of a collection ahead of time. And also another thing about collections is that the position of an item in a collection is not nearly as important as the position of the items in an array. New items are appended to a collection with the add method, while existing items are removed with the remove method. So he says, note there's, when you're talking about arrays, there's no simple method of removing an element from an array. Now we didn't try and remove elements from arrays, but it's not easy. The only real way to do it is just take the original array, and you have to basically copy the original array and leave out the element to be removed. So that's pretty clumsy. Okay, so let's learn a little bit about collections, and we're going to learn first about what's called a list collection. And to define a list collection, you use a statement like this. So this is new, and it's new because we're using the keyword new. So usually we would say dim names as something. Or if it was an array, it would be dim names with the parentheses here as a type of string, or a data type like a string or integer or whatever. So now we have this keyword called new. And this type of collection is called a list. But anyway, we use this kind of expression. Now, actually, this new keyword is very important, and it's really the way you create any object that you want to. So you have a class, and you want to create an object from that class, and you use the new keyword. So if you're not creating, one of the basic data types like an integer or a string or a double or something like that, when you're creating a new object, you have to use the new keyword. Now if you're creating a list object, then you're going to have to declare the type as well. So every item in the list is going to have to be a string. So that's why we have the string there. So all items in this collection, this list, must be a string because we're declaring it of this type. So you can't mix and match. You can't have strings and integers and doubles and so on for a list. And the type of element in the list goes inside the parentheses here, following the word of. Now there's also something that you could do. Instead of just a list, you could call it an array. You could create a new array list, and then you don't have to have all the same type of objects, all the same type of elements. Okay, let's do another, create another collection. Let's do a collection of, this time instead of strings, a collection of color objects. So you can also do this. So here we have dim names as new list. Here we have dim color. This is just the name of the list. New, everything else is the same until here. And then this is color objects or string objects or elements. Now to populate the list, or to give it some elements, to feed into some elements, you just do a statement like this. Same thing here. So when we're adding to the names, we can add these strings. For colors, we have to do we do color add instead of name add, because this is called colors, and we can add these colors. This is a way to reference colors. This is a way to reference a color as well. It's the textbox1 dot back color. So that's a color, and you can reference it this way, and then add it to this list. Okay, now here's another example. This is another collection, another type of collection. It's a bit different from a list. It's called a dictionary collection, not a list collection. And this will enable you to have two elements that you add, where one of them is a kind of keyword that you use to look up the other one. So we have Manfred, in this case, is the keyword, and this is perhaps something you might be searching for. So you could do something like this. After you've entered these values into your birthdays or b-days dictionary, which we'll go back and figure out how to declare it in a second, but after you've done that, then you could do something like this, and what you'll get back is Manfred's birthday. So that's why it's kind of called a dictionary. You look up one thing and you get the result. So let's see how we declare that. So another collection is the dictionary collection, which allows you to identify each element by a key instead of an index value. So we could identify elements, say in the names, list here, by using names 0, names 1, names 2. So we could identify it by an index, names open bracket 0, names open bracket 1, names open close bracket 2, and so on. But now, as I said, we can do, instead of identifying something by an index, we can identify it by this thing, by a string, or by whatever this type is here. So again, another collection is the dictionary collection, which allows you to identify each element by a key. So this is the key, or this is the key, instead of an index value. The following statement creates a new dictionary collection for storing names and birthdays, birth dates. So dim birthdays as new. So all of these needed new, and whenever we create an object, we always will need new. So new dictionary, so we're creating not a list this time, but a dictionary, which means has two parts. And the first part here we're going to say is a string, and the next part is going to be a date. So now when we populate this bdays dictionary by doing this, bdays add, you have to give it both the key, which is a string, and this, which is the date, which is a date. So when we declare it, we're going to have a comma in here, and then what we're going to put in, we're going to have the of word, and then we're going to have the type for the key and the type for the stuff that we're actually trying to store in there. So this, we're putting a key of type string, and the type that we're of the stuff that we're actually trying to store in there is of type date. So after we've added a few elements like this and like this into our dictionary, we can retrieve to retrieve the birth date of Manfred, we can use this statement. Okay, and there's one more that they're going to mention here, one more type of collection. So finally, you can use collections to store custom objects as well. So we're going to make a list, so it's still the same kind of list, the same kind of collection as we saw before, a list. But before, the data type was, I think it was string and color we had in the list. Let's check it again. So here it was. We had two. One was called names, and another was called colors. This one, the elements were of type string, and here they were of type color. But now they're saying that you can do this. So of type check record. Okay? So what is a type check record? Well, if you remember in one of our past videos, I think from last week, we created a structure called check record. So now you can create a list with those. So it's not a list of integers, it's not a list of strings, it's not a list of colors, it's a list of things that you, of a structure that you actually created. So you might have created a structure like this and then created a bunch of checks. And remember well, maybe we should go back and check it. So here it is, the structure that we created. Now remember, a check record has these fields. Has a check number, a check date, a check amount, and a check paid to. So it has all of these. So when you create a list, you're creating an object, basically, or a structure, I should say, and each one of them has these 4 fields. And then, so you might, okay, now remember how we created, so this was, we defined the structure like this, and then we might declare check 1 as a check record and check 2 as a check record, and then we could assign, for a check 1, we would want to assign a check number to it, and a check date to it, and a check amount to it, and a check paid to it. And then we would have finished initializing check 1. And then we would do the same thing for check 2. Now we can take check 1 and add it to our list. So we'll have a list which is check 1, and it'll have all of these fields, and all of these fields will have been initialized. And then we can add check 2 to our list, and it will have all of these fields, and all of these will have been initialized. So really this is kind of like in a sense a two-dimensional array, but anyway, it's what it is. It's we're talking about a list that has as its elements structure. So once again, let's look at it. We create a new list. We call it checks, but it's a new list, and the type of objects that we're adding to it are check records, which are a structure that we created. And then we have check 1, for example, and that's already been initialized. All of its fields have been initialized, and then we add it to checks. All of check 2's fields have been initialized, and we add it to our list checks. All of check 3's fields have been initialized, and then we add it to our list checks. Okay, so we can also do that. And then you can access check 1, or rather, I'm sorry, you can access check 0, and you can get the different fields for check 0. In other words, you can get the different fields for this check 1 object. I should say check 1 structure. Now he suggests that we could, if we wanted to, make it, instead of doing a list, we could do this with a dictionary. In other words, we could have our structure as an element of the dictionary. So we're gonna create a dictionary. We're gonna call it checks instead of just having a list of checks. Let's create a dictionary of checks. So remember, you would get the different checks here, check 1, check 2, check 3, by using an index. But here, if we're going to make a dictionary, we can have some other way. Actually, we're going to make it an integer as well, it looks like. But we're going to make a dictionary, and instead of a list here, so we're going to say as new, don't forget the new, dictionary, and then for dictionary we put a comma. In other words, we need 2 types. So the first type is going to be integer, and the second type is going to be of type check record. In other words, our structure. Now remember that these are also indexed by integers and can be accessed by integers, but these are always, start at 0, then 1, then 2, then 3. But here it doesn't even have to be an integer, but we are using an integer here, but it doesn't have to follow any particular order. So what they're going to do is they're going to, like here, they're going to add something to our dictionary of checks, and we're going to take check 1, which is something we already have, which is an enumeration, and it has a check number, and that's going to be the the key that we'll use as the lookup to find check 1. So then you'll be able to do something like this. This will say checks, and then we want an integer, but the integer that we want is the check number. So you'll be able to put the check number into this, and you'll get out the check object, the whole object. And they say an application that might use this structure, actually I think this should be this dictionary, can prompt the user for a specific check number. So ask the user for a check number, and then you retrieve the check by its index using this dictionary. And by retrieving the check, you get the whole. Remember, the check itself is a structure, and it has all these different fields, and you can get access to all of that. Finally, they say, as you will see in chapter 12, a big advantage of collections over arrays is that collections allow you to remove elements with the remove method. Okay, so we don't get to see that, but that makes it easier to use in an array. By the way, he mentioned up here an array list, which sounds like it might be an array, but it's not. It's a list. It's a collection. Okay? So it has probably more flexibility than just a regular array.